Assalamualaikum and hello everyone, especially to my panel, TS Dr. Nazir Huzaimi bin Zakaria and Dr. Iskandar bin Waini. Today, I will presenting about Bachelor Degree Project 1 and the title is Investigating the Mechanical Properties of Sugarcane Bagasse Reinforced by Epoxy Resin. Before I start my presentation, I will introduce myself first. My name is Muhamad Azamudin bin Nooahdin and my metric ID is B0919104221. I am from Faculty of Mechanical and Manufacturing Engineering Technology and my supervisor name is TS Dr. KHAIRUM bin HAMZAH. These are the outline for my presentation. I will be presenting the introduction, problem statement, objective of research, scope of research, selected literature review, methodology, expected result, and last one is conclusion. For the introduction, agricultural waste is polluting society today, spreading diseases and destroying the beauty of nature. If this waste is not properly disposed of over time, we may not be able to provide a clean and healthy environment for future generations. It is now our responsibility to appropriately dispose of the waste. In this study, the use of waste materials will be one of the main materials that will be used to make composite. Sugarcane is the main crop used to produce sugar. In the process of making sugar, by the product was produced is called sugarcane waste. Sugarcane bagasse can meet the criteria to be processed into the main material in the production of composite. This sugarcane waste has many advantages over other organic filler because it is biodegradable, low cost, and recyclable. Composite material consists of two or more distinct materials, having significantly diverse physical or chemical properties that, when mixed, provide a material with unique characteristics. Composite materials typically have unique features, such as a high strength to weight ratio. Because composite may be molded into the complicated shape, it enables design flexibility. For the problem statement, agriculture and industrial waste dumped and burned in the open cause serious environmental problems. Therefore, researchers have been encouraged to use agriculture and industrial waste as engineering material in a variety of applications. Recycling of natural waste-based material has been widely used in manufacturing engineering, and one of the material is sugarcane bagasse. If natural waste, such as sugarcane bagasse, is not managed properly, it will cause problems, especially to the environment. This waste product is already causing serious environmental pollution, which calls for urgent ways of handling the waste. If the sugarcane bagasse waste is managed well, it will be beneficial. Incorporating bagasse waste into polymer composite is one of the possible applications. This not only lowers the cost of the composite, but it also allows for the reuse of bagasse waste, which help to mitigate environmental issues. Next is the objective of the research. The main aim of this study is to investigate the mechanical properties of sugarcane bagasse reinforced by epoxy resin. Specifically, the objectives are as follows. First is to fabricate sugarcane bagasse reinforced by epoxy resin using different ratio materials. Second is to establish the standard size of the specimen suitable for mechanical testing. And the last one is to investigate the mechanical properties of the fabricated material using tensile, flexural, and impact tests. For the scope of research, this research is focusing on the potential of sugarcane bagasse reinforced by epoxy resin. Hand layout method will be performed in the sugarcane bagasse reinforced by the epoxy resin process to produce a composite material via the different ratio based on percentage of volume, which is sugarcane bagasse 60, 40 epoxy resin, sugarcane bagasse 60, 65, 35 epoxy resin, and sugarcane bagasse 75, 25 epoxy resin. Next, the mechanical properties of the experimental material will be evaluated by using tensile test, flexural test, and impact test. Investigate which ratio could be a better result for the quality and mechanical properties of specimen material. Next is literature review. There are 5 literature review that I selected from all my literature review. First, from Ku et al. 2018. About the title, sugarcane bagasse now be economical utilized because of recent advance in industrial biotechnology. From the finding result, researchers are primarily interested in the mechanical properties of sugarcane bagasse fiber, tensile strength, modulus of elasticity, density, and elongation at break are all mechanical attributes to sugarcane bagasse fiber. The mechanical characteristics of sugarcane fiber are affected by the age of the fiber, the source of the fiber, and various surface treatment process for sugarcane fiber. Next, from Azamudin et al. 2021. The title is The Creation of Natural Fiber Hybrid Composite made from sugarcane bagasse and bamboo charcoal for recycled thermal insulation material. From the final result, natural fiber plus charcoal powder has been shown in tests to be more effective than natural fiber alone. Natural fiber composites are particularly useful in tensile application. Natural fiber like sugarcane bagasse and bamboo charcoal can be used to make composite reinforcement for automotive interior component according to the research. Last one is from Prasad et al. 2020. The title is Sugarcane bagasse Fiber Reinforced Epoxy Biocomposite Physical and Mechanical Properties. From the finding result, the composite reinforced with 15 mm fiber length had the highest impact energy because of the flexibility of the fiber, so it may take in more energy before it breaks. Natural fiber can be replaced in a variety of applications by chemically treated bagasse reinforced composite thanks to their superior physical and mechanical properties. Methodology. As you can see from the flowchart, that have 3 stages on this experimental. First stage is to make experimental material using hand laying technique to produce composite material with different ratio based on the volume between sugarcane bagasse and epoxy resin. Second stage is to cut the material into experimental specimen using a CNC router machine and use 3 types of tests, namely tensile test, impact test, and SUPERVISOR test to determine the strength of the material. Last stage is the analysis of the experimental material. Next is explanation step by step of methodology. Start from preparation of sugarcane bagasse fiber. Then design of material specimen by following UTeM standard size for mechanical testing. Next process is fabrication process. There are 3 different ratio values used, which is SB60 40ER, SB65 35ER, and SB75 25ER. SB is stand for sugarcane bagasse, while ER stand for epoxy resin. Next process is cutting process by using CNC router machine. Dimension for tensile and flexural test is same, which is 120 mm for length, 20 mm for height, and 3 mm for thickness, while impact test is 55 mm for length, 12.5 mm for height, and 10 mm for thickness. Next, there are 3 types of mechanical and physical tests, which is tensile test, flexural test, and last one is impact test. The machine used is Shimizu Universal Testing Machine and Eastron Case 9050 machine. Last one is statistical analysis with ANOVA and bar graph. Expected result for tensile test. In terms of tensile and elongation, the 60 SB 40ER composite ratio was found to be superior to the other SBER ratio test. SBER composite with a sugarcane bagasse content of 60% or more have higher tensile strength according to this finding. To achieve the best tensile qualities, sugarcane bagasse and matrix should be combined in a ratio of 16% to 14%. For the flexural test, the flexural characteristic of 60 SB40ER were found to be higher than those of other SBER ratio. Despite this, the flexural property of this composite is higher than that of the other sample studies. This observation revealed that as the percentage of sugarcane bagasse in SBER composite approached 60%, the flexural strength of the eco-friendly ratio becomes stronger. For the impact test, 60 SB40ER absorbed more energy than the other environmentally beneficial SBER composite ratio. This finding indicates that the lowest percentage of sugarcane bagasse will absorb the most energy during this impact test. This could be due to the synergistic effect of sugarcane bagasse and epoxy, which produce a good share force resistance of 60% and 40% respectively, which account for the improved impact resistance. The impact strength of SBER composite decreases as the percentage of sugarcane bagasse will increase. As a conclusion, the use of materials such as sugarcane bagasse and epoxy resin as a metric in the production of composite has been discussed. The entire process of preparing and producing of sugarcane bagasse fiber is also has been discussed. Tensile, flexural, and impact tests have been used to assess sample strength. All these machines have advantage of their own, and they were used to test the sample strength based on their suitability to achieve the goal of the study. By finishing this study, all planning, method, and preparation play an important role in achieving outcome and performance. Finally, in order to obtain accurate findings from this test, all methods must be carefully and accurately followed with no mistake. So, that's all from me. Thank you.